We're in section 1.7. And we're going to talk about the midpoint and distance formulas. All right, so midpoint. What do we mean when we're talking about a midpoint? What does the word tell us? The middle point. So we're talking about the midpoint of a segment. What does the midpoint do to the segment? Cuts it in half. So midpoint cuts in half. And what do we know about the two pieces? The two pieces that they're equivalent, they're congruent, their lengths are equal. So what we're going to say is the midpoint is the middle, halfway between 2 points. It cuts in half. So we're going to say the midpoint of a segment divides it into two congruent segments. Now, if we have our segment, we'll start out the easy way. We have our segment, and if our segment's laid out on the number line, and let's say we have a point here at -3 and a point way over here at 7, and 0 is going to be, let's say, here. How do we figure out what the midpoint on that segment is? So let's do this. 1, 2, 3. And I'm going to move this over. So how do we figure out what the midpoint of that segment is? What's that? Add it up and divide by 2. So if we, now do we add 3, or do we add 7 and -3? No? So we figure out, first thing we're doing is figure out how much space is between these two. So how many spaces are between these two? 10 spaces. We divide that in half and we get 5. So does that tell us our midpoint is here at 5? And what does that 5 tell us? 5 spaces away from each of these. So what point is 5 spaces away from -3 and from 7? 2. So that's our midpoint. And what we did was we added these two together and we divided by 2. Thank you. Oh, not in next door. Next door? Yeah, 245. So we add these up and divide by 2. Now, if we have nice small numbers like this, -3 and 7, that works okay. If we have really big numbers, -3,872 and 7,526, gets a little more difficult to count spaces and that kind of thing. But we can do the same thing. What we're doing here is finding the average of the two numbers. So when we add them up and divide by 2, we're finding the average. And if we have a point on the plane, we have a point in the plane, so we have our x-axis and our y-axis, and rather than being laid out on the number line, we have something like this. Then it's a little more complicated, but not a lot. So those are our 2 points. we're going to have an x-coordinate and a y-coordinate. So we have two numbers that we have to deal with, an x and a y. And our midpoint for a point in the plane is going to be, we're going to say our midpoint. Now we said we took the average, so if we decided that we needed to figure out how much space for this one, how much space was between the two, and then cut that in half, and then that told us our midpoint was 5 spaces from each of these numbers. If we would have added these two, 7 plus negative 3 is 4, divided by 2 is 2. So if we find the average, that gives us our midpoint. For a point in the plane, the midpoint is the average for the x and the y. So our midpoint formula is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And this gives us our new x and y for our midpoint. For a midpoint, we end up with two numbers, one for the x and one for the y. And what we're doing is taking the average of the x's and the average of the y's. And that's how we find the midpoint if we're in the plane. And for midpoint, we always end up with two numbers. So let's take a look at how we are going to use the midpoint formula. Questions on this piece? We're finding the middle of the x's and the middle of the y's. To find the middle, we are using the average. All right, let's do a couple of examples. So we want the midpoint between 3, negative 2 and 4, negative 7. What I'm going to suggest that we do, always when we're working with the midpoint, is label these x1, y1, and x2, y2. Doesn't matter which ones are 1s and 2s, but the 1s and 2s have to stay together. I can't mix up the 1s and the 2s. And we know that our midpoint, I'm just going to say mid PT, x1 plus x2, so 3 plus 4 divided by 2. That gives me my x. And I have two numbers, always two numbers with our midpoint. And then y1 plus y2, negative 3 plus negative 7 divided by 2. And that gives me my y. Yes. Negative 2, thank you. All right, so 3 plus 4 is 7 divided by 2. I'm just going to write that as 7 divided by 2. That's my x. And negative 2 minus 7 is negative 9 divided by 2. I could leave my answer written like this, 7 halves and negative 9 halves. Or I could turn it into a decimal. 7 divided by 2 is 3.5. And 9 divided by 2, negative 9 divided by 2 is negative 4.5. So the midpoint between these two points is the point 3.5, negative 4.5. And we have two numbers, an x and a y. Let's look at another one. Another way you might see this question is it will say a segment with endpoints, negative 2, 3, and negative 4, 6. And we want to find the midpoint. So anytime we have coordinates like this and we're finding the midpoint, we're going to be using our midpoint formula. So we go through this procedure again. I'm going to label this one x1 and y1, x2 and y2. Doesn't matter which one is 1s or 2s, as long as the 1s stay together and the 2s stay together. So I'm going to say the midpoint, x1 plus x2, divided by 2, and y1 plus y2 divided by 2. And then I'm just going to simplify this. Negative 2 plus negative 4 is negative 6. Divided by 2 is negative 3. And 3 plus 6 is 9 divided by 2, and we decided that was 4.5. So we'd have the point negative 3, 4.5. And remember, we're always getting two numbers here, an x and a y. All right, questions there? Okay, let's look at an example that's a little trickier. Let's say we know the midpoint and one endpoint. So we know the midpoint of segment LM is 2, negative 1. One endpoint is L at the point negative 3, negative 5. And we want to find the other endpoint. M. So this time we have the midpoint and one endpoint. And we want to find the other endpoint. We're still going to use the midpoint formula. Since we don't know what this other endpoint is, let's call it the point x, y. We don't know what it is, so let's just call it x and y. Let's give it a variable. And we're going to go through the same procedure. We're going to label one endpoint x1, y1, and I'm going to label the other endpoint x2, y2. I just don't know what this is. And then I'm going to say my midpoint, negative 2, negative 1, and remember this is my x coordinate and my y coordinate, equals x1 plus x2, negative 3 plus x2 over 2. And my y coordinate of my midpoint is y1 plus y2, negative 5 plus y2 over 2. And this also tells us x and y. Well, this piece has to equal that, and this piece has to equal that. So we have two equations. We're looking for two numbers, so we have two equations. So let's work with this equation. Negative 2 equals minus 3 plus x2 divided by 2. I want to solve for x2. I want to get x2 by itself. So how do I get rid of this 2? Multiply both sides by 2. These cancel out. Negative 2 times 2 is negative 4 equals negative 3 plus x2. I add 3 to both sides, so I'm going to turn this around, so x2 equals negative 1. Now let's work with this equation. Negative 5 plus y2 over 2 equals negative 1. So I'm working with the y equation. Same process, I want to get rid of that 2, so I'm going to multiply both sides by 2. Those cancel. I get negative 5 plus y2 equals negative 2. Add 5, and I get y2 equals 3. So m is x2, y2, is the point negative 1, 3. So I have one equation for the x's and one equation for the y's. But we're using the same formula, going through the same procedure, labeling my points x1, y1, x2, y2, and I just solved 2 equations. Questions there? All right. Our last formula, the distance formula. So if we have, let's go back to our number line. If we have our segment laid out, it's really nice and just laid out on the number line. How do we find the distance between points A and B on the number line? What do? Count spaces. We just count how far it is between A and B. If we're not on the number line, it's a little more complicated. So here we just count spaces. If we're in the plane, it's a little more complicated. So same picture that we talked about before. We have our 2 points here and a segment connecting them. We can't just count spaces along this line. It doesn't quite work that way. But we have a nice formula that works if we have these points in the plane. The distance, we're going to say d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And this isn't some kind of mysterious formula that someone just made up. What it is I turn this I draw a little triangle here, and I have a 90-degree angle there. And what this is the Pythagorean theorem. A squared plus b squared equals c squared. So I'm finding the long side of my triangle using the Pythagorean theorem. Because the Pythagorean theorem works for right triangles, we can use the distance formula to find the distance between these points. So our distance formula comes from the Pythagorean theorem. All right, questions on where this comes from? All right, so let's look at a couple of examples using the distance formula. All right, so the distance. Let's find the distance between (3, 5) and (-2, 6). So we're going to do the same thing we did before. Label our points, x1, y1, x2, y2. The 1s and 2s need to stay together. Doesn't matter which ones we call which. And I just plug these points into my formula. The distance is going to be the square root of x2 minus x1, negative 2 minus 3 squared, plus y2 minus y1, 6 minus 5 squared. So here's where we need to be careful. This is the square root of negative 3 minus 5 is negative 5 squared. 6 minus 5 is 1 squared. Once I finish squaring everything here, I should never end up with a negative in the square root, because whenever I square a number, it always turns it positive. Negative 5 squared is positive 25. So this is the square root of 26. And if I plug that into my calculator, what do I get? Someone have a calculator? Tell me what square root of 26 is. 5.3 something. Does it come out to? Someone calculate this for me, please. 5.099. Okay, so we'll just call it 5.1. So the distance between those 2 points is about 5.1 units. So when we square a number, it should always turn positive. You should never end up with a negative number under your square root. So let's look at another one really quickly. Students often make mistakes here. So we want the distance between negative 2, negative 3, and negative 4, 5. So let's label our points x1, y1, x2, y2. And my distance is going to be the square root x2 minus x1, negative 4 minus negative 2 squared, plus y2 minus y1, 5 minus negative 3, and we're squaring that. Negative 4 minus negative 2 is negative 2 squared, plus 5 minus negative 3 is 8 squared. Negative 2 squared is positive 4. And 8 squared is 64. So we get the square root of 68. And when I plug that into my calculator, I get 8 point something. Someone calculate that for me. 8.2. So the distance between those 2 points is about 8.2 meters. All right, questions there? All right, let me put your homework up. We will go over the algebra review. And then we're going to do a little activity, and then we'll have some time for our homework. Page 54. All right, there you go.